Hello everyone, welcome to join my session today. My name is Liang Yan. I'm a software engineer from SUSE virtualization team. Today I'm going to give you a topic about how to accelerate your AI cloud with SUSE Linux. As we know, AI or machine learning techniques have become quite popular today, and a lot of companies have set up their own AI cloud infrastructure. Today we are just to see how could we accelerate this cloud from a GPU virtualization perspective. Uh, Here is today's schedule. First, we'll have a look at the background of AI cloud and the hardware accelerator, figure out why we want to use them. Then we'll go to NVIDIA GPU virtualization, figure out why we want to use it as a hardware accelerator solution. Uh, Second, we'll have a look at SUSE GPU virtualization. I'll give you a status update, show you the capability of our vGPU, and also give you a demo of how to run it in on Linux. Last, we'll have a look at the future plan, so you can coordinate it with your development roadmap. So let's begin. First, if you worked on AI or machine learning before, you probably found this picture quite familiar. There are actually two stages here, the training part and the inference part. It's actually also the basic architecture uh, for general AI usage today. It's how we use them. First, the scientist will design an algorithm to train a model from the training data. Then we'll deploy this model into a real environment and let this model to do the prediction based on the input data. So if we only speaking of this, there's actually no necessary for AI cloud or hardware accelerator if you are patient person. However, it's quite different if you use it inside a company across different teams. You need to thinking a lot of other components together, like testing, CI/CD, uh, data management, and so on. So eventually, it will become architecture design like here, AI cloud. And comparing an AI cloud to a normal cloud, the big difference is actually the center part here. The AI platform like TensorFlow, PyTorch, First AI, and so on. The one main purpose of this platform is to dealing with the huge amount of data in a really short time. So we really need a hardware accelerator for it. But also remember, we also want this hardware accelerator could feed the whole AI cloud. Anyway, let's see what kind of choices do we have. So uh, currently there are three different kind of types: GPU, FPGA, and ASIC here. GPU is the mainstream type. So we know there's NVIDIA, AMD, and Intel GPUs here. And they were using the OpenCL or CUDA library for the acceleration. They are mainly using for the training part. They are very a good candidate. FPGA is becoming quite popular too. There's two main vendors, the Altera acquired by Intel, Xilinx. There's also rumor that AMD is going to acquire Xilinx. We'll see. This FPGA will use OpenCL for inference mostly. The other type is ASIC here. It's actually a specific FPGA. One famous one device is actually the Google DPU, Tensor Processing Unit, uh, which mainly used for the TensorFlow. This could be used for training. All the others are mainly are the AI chips. For example, the mobile phone today, they already have AI chips along with the normal CPU. These kind of uh, chips are mainly for inference. So anyway, we actually choose NVIDIA GPU utilization as our solution. The reason we choose it is there's actually too many reasons. First, it's quite powerful. They have a very good software ecosystem. For example, the CUDA. As we know, NVIDIA is the only GPU that could use CUDA directly. They also implement all kinds of framework from the different levels of AI platform. It also has a very good hardware performance, and the improvement is even more surprising. You can see that uh, each improvement, each generation, is much better than the previous one. The other reason is actually we discussed earlier for the AI cloud part. We want this accelerator could fit for AI cloud infrastructure. Actually, the full GPU utilization provided by NVIDIA could fit a cloud platform very well. First, it provide a very good scalability. So we could use multiple GPUs based on one physical GPU. And it also has very good security. We could isolate each GPU into different VMs. And because of the hypervisor layer, we could avoid the system failure from some attack. And also it has a very good flexibility for management. We can do the snapshot for backup. We can do the migration between different servers. We can even do live migration. The VGPU manager actually also provide a monitor feature here. It's quite useful for a cloud platform. Anyway, it's a very good choice if you want to accelerate your AI cloud. So we actually built partnership with NVIDIA for a while last year, and we worked very closely with them. Still working closely. We actually just released our vGPU based on 50SP2. Before we release it, we did a complete evaluation. We set up a platform based on 15SP2. We also ran tests on different VMs, SP2, SP1, even some Windows server. We choose SPE server and NVIDIA V100 as the hardware. We also run some benchmarks recommended by NVIDIA. So we did all the essential functional tests here. We make sure the driver, the VGPU driver, is compatible with our server. The CUDA is compatible with our library dependency. The 3D graphic could work. We could access by remote display, and we could run multiple VGPU at the same time. So besides these functional tests, we also run a couple of performance tests between vGPU and the GPU pass-through. We also test the vGPU across different guest VMs. We try vGPU with different memory configuration. We also test its scalability performance. So first, Let's show you the graphic performance results. Actually, the default setup for graphic is not very good. Then we came to the NVIDIA team, got some feedback, and then we did some optimization based on that. Then we get a very good result after that. It's actually surprisingly well. You could see from here. Uh, Computer performance side is quite stable. You could see that with GPU performance is very close to GPU pass-through. So anyway, based on our tests, we found some conclusions here. First, there's no big difference on computer performance between vGPU and GPU pass-through. So that's a very good result we want. And also we found similar results between different VMs. We also found that during a lower workload, uh, the performance actually shows the same for different vGPU memory size. That, that actually makes sense because per their design architecture, each vGPU actually share the whole physical GPU resources based on a time slice. So if the workload is not beyond the memory size, so it would have a very good performance. We also tested different profiles. Like for the computer workload, we test C, 16C and 16Q. There's no big difference. For the scalability test, we found that it did impact the performance, but still better than our expect. So for our tests, we checked this kind of feature lists. So remote display, you could access by a what viewer or what manager. If you're using what manager, make sure you're using Control 2 to switch between different viewer. And we can see the graphic performance is actually pretty good, even sometimes better than pass-through. And the CUDA and AI framework run well in our guest VM. The computer performance is pretty stable. We could do the snapshot and even line migration for 15SP2. 800 or say Ampere GPU card support here. It's still ongoing since this is a new product which use a totally different architecture. But we are going to make it work on 15SP3. We're also working on the security boot for vGPU. They're still working. There are still some works going on there. Anyway, let's show you a demo here. So we are using, we set up this demo based on 15SP2 as host and guest. We handled on SP server. So basically three part. You need to register account from NVIDIA side, get the license, and download the driver. Then you set up a license server locally and configure your vGPU inside the VM. After that, you just set up your application, AI application here. We are using NGC service provided by NVIDIA. Anyway, let's have a look on this demo. So as I said, first you need to go to NVIDIA side, register account, get the license, download the driver, the vGPU driver and the license server. This is just some trial license. You need to find the drivers here, download them. I already downloaded them. So find the license manager here. For the license manager, actually there is two part of it. NVIDIA side and the local side. For NVIDIA side, so I already create one. Let's delete it and create a new one. Just fill it. You need to get the MAC address from your local license server, which means you need a separate machines or even VMs for this license server. Get the MAC address here. Also add the licenses. The number depends on how many vGPUs you want to use for the VMs. So once create it, you can generate a bin file here. This bin file need to be used by your local license server. Here, you need to upload the bin file here. Once uploaded, you could see the capability. Now the license server setup is done. Let's get to the vGPU manager setup. We already downloaded from NVIDIA side. The process is similar with a normal NVIDIA GPU driver. You just install it and verified by NVIDIA SMI. The difference is that there will a couple more kernel modules for vGPU manager, like here NVIDIA vGPU VFIO. So after this installation done, you need to reboot. After reboot, you could find this MD supported types folder and all kind of different vGPU types here. We need to use the UUID for vGPU creation. I use UUID here, but you need to use a real UUID number to create it. For example, here, this is a UUID looks like. And once you create it, there's a folder here with the name of UUID. Let's get inside. You can use the echo 1 to the remove to delete your vGPU. You can also check the vGPU information with under the name, types and name. So it's a 16C here. Anyway, we created the vGPU here. We just add them to our VM environment here if we want to use a vault manager. You can just add here. It's quite a straightforward. And Control 2 to switch between different display. And let's check the device. The latest thing here is just because I access the server remotely. It's the network issue, not the vGPU performance. So anyway, let's access by SSH. Here. Log into the VM. Install the driver here. Already done. Verified by the NVIDIA SMI. Now we have a VM with vGPU. You can see I already installed CUDA here too. Now we are just set up an AI application based on the NGC service, NVIDIA Graphic Cloud. You also need to register account. To register API key here, process is straightforward. You can just follow the instruction. Once you register your API key, you can just download the image for your AI application. We are using TensorRT here, so you could search different service here from the catalog. We are using TensorRT for V100. So it's actually a Docker image. We just pull the image from NVIDIA server. I already did. You can see it's there. Now we just run this image. Make sure you're actually using the vGPU as the accelerator. Now we are in a container environment. The benchmark. I actually not a AI platform or benchmark expert, so let's just copy and paste. Copy the command line here. Paste. Make sure to find the right engine here. Now, voila, you actually have an AI application running in a VM. It's much easier than you really set up a AI platform. So, yeah, I think that's for the demo. Don't worry about the setup. You could find the instruction from NVIDIA side or from SUSE side. Now let's get to the last part, features. So as I just said, we currently have vGPU 12 released based on 15SP2. SP3 haven't released yet, but from our initial evaluation, it could work well. So far, we are just working on the Ampere GPU support and the line migration feature support. So besides this vGPU featured here, we actually also did a lot of other exploration. First, like for the ARM64 platform, we actually enabled the GPU on ARM64 recently. And then I did this test for pass-through. It also could work well. We also tried to explore other user cases for vGPU, like using vGPU in a Kubernetes environment by KubeVirt, or in a SUSE manager, or just in a lightweight VMM, like Rust VMM. So we are kind of excited to doing it. Also, besides NVIDIA, we also have the partnership with other vendors like AMD and Intel, ARM here. For AMD, we actually have a regular meeting with them on this Instinct GPU support based on the MX GPU JRM module. We also, for the Intel side, we know that currently it's all integrated GPU, but the rumor says that they will have a dedicated GPU releasing soon. So we are kind of excited to it. We also have partnership with them, so we are working on that immediately after this card coming out. So for the ARM side, there are actually two directions. First is for their own GPU solution, Marley GPU virtualization. They actually announced it a few months ago. It just we don't have the hardware to really implement it yet, so we'll keep close to it. The other one, I think, it's just a normal ARM platform to support the GPU. So I think a famous one is that NVIDIA just announced Grace CPU. specific use for AI cloud. So that's that's quite interesting. Anyway, that's all for my topic today. I hope you found something helpful. If you have any questions, I think there's a SUSECON feature called Brain Date. You can find me there, and I would be glad to help with your questions. Anyway, thanks for attending my session here. Enjoy the rest of the SUSECON. Bye.